Welcome, everybody. We appreciate you all coming in. I know it's Friday. We have a great opportunity for Convergia to showcase and discuss one of our key market partners, Libelium, which is truly one of the finest in sensor organizations. John Wood is with us here today. And the discussion is going to be around environmental quality measurements for sustainable cities. So John's got a fantastic presentation that he's going to be presenting. We are going to have some time at the very end, hopefully, for questions and answers. We'll hold all of those till the last 5 or 10 minutes. If you do have some specific questions, we ask that you put those in the chat box and we'll get to those. And if there are any additional questions at all at the end that we could not address and get to, we'll make sure that we get those to everybody in email form. And we'll also send out a copy of the presentation to everybody so that you have that as well. Okay. So I want to just take a few minutes. First, for those who aren't 100% familiar with who Convergia is, we are a 20-year organization with extremely strong ties in Pan America. So we are corporately headquartered in Montreal, Quebec, which is in Canada. Our US headquarters is in Miami, and our president, Alejandro Botar, sits in Lima, Peru. As a Pan American company, right, we focus on the aggregation of a variety of the largest distributors of both wireline and wireless networks across the globe. We provide managed services throughout, and we have local offices, service and delivery, and the capability of doing billing, as well as the currency of the local country throughout Pan America. This just gives you an idea as far as where we have presence currently today. Again, not only are we in the US and Canada, but we're in multiple countries throughout Latin America and have that capability of doing local billing and services right there. As far as our pillars go, CXC, or connectivity by Convergia, the connectivity is our foundation of the organization. We can provide aggregated wireline solutions, both from data or wireline as well as wireless. We provide SD-WAN, Wi-Fi. We can provide bundled services on the wireless piece for either failover backup or for primary. We also offer a variety of different voice products. And as you can see, also, we have a variety of additional managed solutions. The CXC IoT solutions, and that's where John Wood and Libelium come into play currently today. We have the ability to talk about smart agriculture, smart water, smart environment, smart marketplace, and John will get into that in detail. So in today's discussions, I believe we're going to go over 3 primary areas, and that's the noise pollution, air pollution, and water quality. And John is going to talk about how his organization can provide the necessary metrics for cities all over North America and Pan America to be able to analyze, utilize, and make conscious decisions from that point forward. So that's a quick, easy summary of Convergia. I want to convert it over to John. I know he has a long presentation. I want to make sure he has enough time to go through his piece. So John, I'm going to stop sharing, and I'll let you take over from here.
Okay. Many thanks, Kevin, and Convergia, and thanks to everybody here who's turned up for the webinar. I trust you can see this presentation, yeah? Can you confirm that, Kevin?
Yes, we have it.
Okay. Right, okay. Here to talk, what I'm going to talk about, a little bit about who Libelium is. We've been in this business for some years now. Just in case you didn't know us, I'll talk about who we are, what we're in essence in this area, what we're trying to solve, because We're oriented to try it and use our technology, or to use our technology to solve problems in different areas. Okay, so we're talking about specifically the area of environmental quality measurements, okay, for cities particularly. Okay, I'm going to talk about how we do that and a little bit about our experience. So I'll try and move on quickly so we've got a little bit of time for questions at the end. Okay, so quickly talking about Libelium, who we are. I won't dwell too long on this, but we basically, in summary, what we are about is to use our technology, okay, to bring the highest quality data to where it's needed to make actionable decisions, really to work towards what we call a datacratized society. It's like a democratized or datacratized, data-driven society, okay? So we design and develop technology that is capable of providing that data. So the technology is right from the sensors in the field, right up to the application level, and even artificial intelligence algorithms on that to make the data as actionable, as relevant, and as meaningful as possible, so the best possible decisions can be made with that data. Okay, so again, we work very closely with our clients and with our partners, such as Convergia, really to achieve that. We have to understand properly what the problems are we're trying to solve, and to really to apply the technology as intelligently as possible to help these problems to be solved, to provide these insights onto what's going on out there in the environment. Okay, so moving quickly on, what are we talking about here? What's the problem? What's the issue with city environments? And as Kevin said, really we're going to center this around, there's a lot could be said about what's wrong with city environments, but what I'm going to center this around, this presentation around, are three main areas, okay, which are air pollution. Just to give you a quick sort of image of what that means, we all pretty much know what that means there, as you can see in the image. Doesn't look too healthy at all, but it's pretty typical in a lot of cities. Water pollution. Waterways are a large part of cities, and they do affect life in cities significantly. And finally, noise pollution, often overlooked, and is a significant factor in cities that should be monitored, managed, and controlled. Okay, so first, talking about air pollution, what do we mean by this? Well, we kind of know what we mean by air pollution, but I'm using here a lot of quotes from real organizations in the US. Okay, so this is from the National Institute of Environmental and Health Sciences. Okay, so air pollution is a mix of things that are basically not very good for us. Okay, that can be produced by humans or produced even by natural sources. Obviously, in cities, vehicles are a large part of that, but there are many other sources of air pollution, such as natural gas, manufacturing, conventional power plants, factories, and so on, chemical production. These are not necessarily in the city, but their pollution travels and they can affect the city. And nature itself releases hazardous substances into the air. Wildfires is something that you're experiencing at the moment in the US. You can look at that. And volcanic eruptions in Mexico. I was there just a week or so ago, and there was a volcanic eruption there that it does affect the pollution across a wide area. And of course, methane, decomposing organic matter, all of these factors contribute to making the air not as healthy as it should be. There is one significant factor in air pollution called particulate matter. Now, this, as it's stated here, is probably the most damaging pollutant in the US and really across the world. And as the diagram shows here, we're talking about very, very small particles, less than the width of a human hair, less than grains of sand. And particularly damaging among those particles are the very fine ones, so the PM2.5, which, are a fraction of what is PM10, which in turn is a fraction of the width of a human hair. So these types of particles can get not only into the lungs, but also into the bloodstream. Okay, you have to excuse me, I'm going to be a bit alarmist here, but but we need to talk frankly about what issues there are in the environment to solve. Okay, so the consequences of this in terms of the US, here's some data. Okay, we're talking about, you know, nearly 9 million people in the US exposed to deadly particle pollution spikes. Okay, and more than 137 million Americans, which is, I guess, over a third of the population, live in counties with unhealthy air, which is obviously not good. Okay, and this not only has this sort of health and social consequence, but also has a monetary consequence. Okay, so here's some figures. Costs every American an average of $2,500 a year in extra medical bills, and the national price tag, $820 billion. Okay, and again, contributing towards many premature deaths annually, according to this research. So it's a very serious issue that has to be looked at.
And
okay, this
and
here,
John,
yep.
I was going to say it's interesting. Prior to living in Charlotte, I lived in Denver, Colorado, and in 2021, between the California wildfires, the massive wildfires that were taking place on the west coast of Colorado, in addition to the wildfires that were coming in from the western portion of Canada, the air quality was about 4 times higher than the safety allotment that they consider, you know, even good to be outside. So the state of Colorado was continuously measuring, monitoring, and providing out warnings because it's a very active state. So people who are doing runs, going out for swims, bike rides, all that information was being utilized to help individuals on when they should go out, not go out. So it's and that's just a very small little piece, but very interesting.
Yeah, absolutely. And you know, it can affect certain populations disproportionately, or certain segments of the population disproportionately with respect to others. Okay, particularly marginalized populations that might be closer to sources of emissions and so on. But definitely wildfires. Talking about wildfires, here is an animation. This is recent data of the wildfires and the pollution that the air contamination that they're causing. That's marked. You can actually, the map is a little bit strange because it kind of twists around, but you can see that goes across from the US, right across the north of from Canada, north of the US, and towards the top right, towards even the north of the United Kingdom. So these wildfires don't just affect where the wildfire is; they do spread the polluted air a significant distance. Okay. So that's in very quickly air pollution. Okay, water pollution. Water pollution is many and varied. Okay, pretty much everything ends up washing into the water. Some of that particulate matter that comes from wildfires can also end up in the water. Lots of human activities, wastewater, trash, etc. All of this, particularly in cities where we share water resources, can end up in the water, and that in the end can get into the drinking water, and obviously in water bodies where people recreational water. Okay, so it's something it's really polluted by many different sources. Okay, and wastewater discharges from industrial and commercial sources can get into the public owned treatment works. Okay, and really overload them with contaminants. Okay, in terms of consequences, I'm just citing here. We pretty much all know what happened in Jackson, Mississippi, with the water contamination there. Had very serious consequences, with millions of people affected downstream. And in terms of financial effects, well, estimation's been made of to billions of dollars a year. Okay, in terms of illnesses caused by polluted water. So it's a serious matter that must be monitored. Noise level is often overlooked. Okay, how do you define it? It's not just any noise. Noise in terms of pollution is defined as a sound that you don't want and that basically disturbs you. Okay, so noise affects all living organisms, humans and animals, and what it tends to do is to raise our stress level automatically. Okay, and the World Health Organization defines noise any noise above 65 decibels as noise pollution. Okay, so noise becomes harmful when it gets over 75 decibels and painful over 120 decibels. What does all this mean? Okay, here's a diagram just to explain to you, what that is. Anything from a whisper, urban environments. You see on the left, passenger cars, medium trucks. That's in the 70 to 80 decibels. So that now is definitely noise pollution that causes our stress levels to increase. And of course, anything like a jackhammer, construction works, and so on, these are even higher and are quite harmful. Okay, and I'll just give here, just for your reference, some terms that are often used in this. It's a whole area I won't get into here, but it's important to, dBAs is the noise level, but adjusted to how we hear it. Okay, and that's Libelium's equipment is actually adjusted to measure in the same way as humans perceive noise level. Okay, so in terms of consequences, again, hundreds of millions of individuals exposed to noise level, tens of millions more may be at risk of heart disease, according to the National Center for Biotechnology Information. So these are all reliable sources. Okay, and this is often overlooked. We'll think that pollution is just air and water, but there's also this source of pollution, and particularly in cities. Okay, so again, this has a financial effect. Anything that can affect people's health has, again, a financial repercussion for a country, for a city, in terms of people getting ill, basically, by this source of pollution. Okay, so a lot of this can come from road traffic, which is obviously in cities, particularly in the center of the city, is something that's the constant source of both gas pollution and noise pollution. And this is just a summary here of, we're talking how does it affect our health? Well, obviously sleep is a major factor. You've got to get good quantity and quality of sleep to keep your health up. Okay, so bad quality and quantity of sleep can lead to hypertension, reduced learning for children trying to study, productivity, etc. As I was saying, increased stress. All of this is bad for your health. Okay, and that is related to heart disease mainly. Okay, and I'm not leaving out the part which is extreme noise, such as jackhammers and so on, that can go in and affect hearing permanently. Okay, so this is an important contaminant in cities. Okay, so I've gone over a few of sort of alarmist, if you like, worrying factors that there are in any city and in US cities, and what their consequences are. But what I want to talk about here, exactly, obviously, Libelium, what we can't do is make cities quieter or necessarily, the water cleaner. But what can we do about this? Okay, so there is an adage here. This is often quoted, but it's a misquote. If you can't measure it, you can't manage it. Okay, so what Libelium's part in all of this is to provide the data. Okay, so in terms of data, in smart cities data, as it says here, from this source from government technology in the US, data is the cornerstone of a smart city. Okay, with data, you identify trends and patterns, you get insights that you can enable you to make the best possible decisions. Okay, so what Libelium's part in this really is to provide, with our IoT solutions and our artificial intelligence services, the best possible insights to drive the best possible decisions that governments can use to bring in measures governments and the private sector to do things to help reduce these sources of pollution in air, in water, and in noise. Okay, so that's Libelium's part in this. You can't really do anything unless you measure what the situation is at first, and then during and after your measures to ensure that they're working. Okay, so just moving quickly on to what our environmental monitoring solutions are. Okay, First of all, we have a product we call the air quality station. Okay, so this product, this solution has 5 gas sensors in. These gases are, along with particulate matter, are the gases involved in calculating what we call the air quality index. Okay, so this gives hyperlocal conditions of air quality, and you can even integrate noise level sensor into there. So it has the potential to be a complete environmental monitoring solution. Okay, with the additional sensors, it communicates wirelessly. Okay, this solution gives something approaching the accuracy you will get from a reference station, which there are dotted around cities, and that cost hundreds of thousands of dollars and require frequent calibration every 15 days. Excuse me. This is pretty much an autonomous solution, doesn't require that level of intervention. Okay, so you can install it around cities in parts of cities that you particularly want to monitor the air quality of, for example, near schools, near hospitals, etc. And this is constantly monitoring the air quality. And if you want, it can also monitor the noise level. And you can even integrate a weather station, which can bring in even more data about what the hyper-local conditions are, how the air may be moving in that area. It enables, if you like, in the application level, richer data sets in order to model what's happening on the ground. Okay, so this is an all-in-one solution for environmental monitoring. And this is 100% designed for harsh outdoor conditions to be installed on the street. Okay, so there's you can see here a little bit of an expanded picture. On the bottom, those 5 discs are the gas sensors. And you see that's like a cartridge that you can replace, because gas sensors are an item. They're electrochemical typically, and they have to be replaced typically about once every couple of years. So this solution is completely modular. You can do that easily by unscrewing that cartridge and screwing in a new cartridge, which we would send pre-calibrated. And the other sensors shown here, the top left is of the other sensors is the particulate matter, the noise level sensor to its right, and underneath that is the weather stations that we use from this reputable suppliers that give a complete indication of precipitation, wind, solar, radiation, etc. All of these factors can contribute to the repercussion of air pollution on people. Okay, so that's in every single monitoring point. That's the air quality station. Okay, to go to if you like, a more dedicated solution, I said before that particulate matter is a special worry, okay, in cities, and so is noise. So we have a data logger, a much reduced size, that's not measuring here the gases, the carbon monoxide, nitrous oxide, and so on, but it can measure the particulate matter, and it can measure the noise level as well. Okay, so this is more a reduced and specialized solution. I've included there a photo. You can actually see the size of this data logger next to a laptop. It's very compact, very easy to install, very quick and easy to install. You can install up to 4 different sensors. Okay, in this, you can swap the sensors around between data loggers. The Libelium 1 is a universal data logger, so you can use it for both air quality and water quality. So you don't have to have different models for different environmental monitoring. Okay, we can even integrate pollen detection with the particulate matter sensor and with some machine learning algorithms up in the application level. So that's very useful information, as Kevin was saying before, for people who do outdoor exercise. Particulate matter and pollen is something that can be a very useful information on a hyper local level, not just saying that the city has so much, but this part of the city, this route has such and such a level of particulate matter or of pollen. Okay, so this solution communicates, this data logger communicates over the 4G network. Okay, and it has an integrated SIM inside, integrated antennas. It's just very much a plug and play solution to install there. Okay, it's just a closer look at that with the different sensors you can attach. Again, you can attach a weather station to provide additional data that allow you to really see the context of that data and enrich the data more by knowing how much wind speed, wind direction there is, the precipitation, etc., the solar level. All of this comes from the same data logger. So all of these units are getting the highest quality data possible and sending it up to where it's needed to make decisions, make actionable decisions. Passing on to water, okay, the same data logger, the Libelium 1. Okay, here we can have a number of different sensors. There are lots and lots of different water sensors that are out there and possible that we can integrate. But here I've included some sensors that basically indicate the health of water. Okay, you can go after very specific parameters like like a processed oil or refined oil or crude oil or even bacteria if you want to. But with pH, with dissolved oxygen reduction potential, and turbidity, you have a pretty good indication of the health of the body of water. Okay, we can even integrate there a detector of the water level, so you can combine that with detecting if the water is overflowing, if there's been a storm, etc., all in the same data point. Okay, and this can be solar powered, so it can be easily distributed and easily installed in remote areas, which often is the case for rivers and so on, and even in coastal areas. Okay, so this is a unit. The same Libelium 1 unit can be used for getting data on air quality through particulate matter, and also for water quality. Again, the advantage is that it's distributed, it's autonomous, very flexible. You can update the software remotely. Okay, it can be used for fresh water and seawater. Not all towns are in. Some towns, again, on the coast, and the coastal conditions are significant for the quality of life in the town or in the city. This can be installed, for example, even on buoys that are floating off the coast to get the water quality that's just around the coast, and they're robust enough to be installed in that way, and have a significantly low power consumption that you can be powered off a battery and a solar panel, excuse me. Okay, all of this data can be uploaded into Libelium. Again, covers from the sensor right up to the application level. We have an application called the Libelium Cloud. Okay, and our solutions can and do communicate to the cloud and through the cloud. Okay, so this is just a quick snapshot of what it looks like. Here you can use the cloud as a graph, as a data reception area, to display the data that's coming in. If you want that just the cloud, okay, but also you can use it as a kind of a gateway. It's frequently the case that people will have their own, or organizations will have their own dashboard. So you can use the cloud as a dashboard, or you can use it as a gateway to your own dashboard. So the data comes up through the cloud. The cloud is used as an element manager to configure the equipment, of course, but it's also used as a gateway to pass the data on to where it's needed, because there may be municipalities that have their own dashboards, organizations that have their own dashboards. So it's very quick and easy with one of these connectors, which may be specifically for Microsoft Azure or AWS, or a general one like HTTPS, just to quickly configure a connector to get the data across to where it's being used in the municipality. Okay. So with all of that, those elements of IoT solutions that we can use to monitor the environmental conditions in cities, we just talk a little bit about what we've actually done here. How are we doing for time? Just let me look. Yeah, we're doing pretty well. Okay, so Libelium's experience, we have experience really worldwide. Okay, Libelium operates from New Zealand through Europe right across to the Americas. Okay, so we can bring in a lot of that experience and you can capitalize in it for your projects. It's enabled us to see how important data is really to improving the quality of life for in cities and in all types of environments. So just to go quickly through a few examples that I think are significant here. Here we have in California, in Cal State, we've installed our environmental monitoring solutions into intelligent light poles. This is a very common mounting asset used across, for example, cities and university campus types of installations. Okay, and this is something that can be, you can have multiple systems in the light pole. Light poles in general, you see, are great for this type of solution to be attached to. Okay, you can put it at the right height out of harm's way, but close enough to people to measure the data that's affecting them. And you can, obviously, you've got a power supply there, which is very useful. The connectivity either through the pole's Wi-Fi or through 4G, etc. Okay, so this is how our solution here. This is a previous model. Our plug and sense model was actually integrated into the body of the intelligent pole, and the data logger here, the node, communicates either over the pole's Wi-Fi or over the 4G network through our cloud, as I was saying before, through Microsoft Azure and to the infrastructure of in this case, the university. Okay, so that's a way of getting the sensors out where they're needed, out where people are. Again, this is a similar project in Cartagena in Spain. Again, used in a light pole to basically collect data on noise level. You can combine obviously surveillance cameras there, other sensors, air quality, etc. And all of this is communicated over a cellular network, to where it's needed. I've included there on the link a little video that you can watch if you like at you know your own leisure. I won't put it on here. It's just a few minutes, and it's got even though it's based in Spain, it's got English subtitles if you need that. So that really comes from the municipality saying how this is helping them to get insights into the data that's happening on the ground, that's taking place on the ground, and that's affecting their citizens. Okay, so that's data on noise level and data on air quality, particularly here. Same project again here in our home city of Zaragoza. This is noise and crowd monitoring, another sensor that I haven't spoken about in this presentation, but it's something that's very useful as well to contextualize what's happening on the ground. It's a sensor to actually estimate the number of people that are moving through an area. So you combine this with the noise level and get very interesting insights on what's happening on the streets in your city, how people are moving, and what's their environment. Okay, so you can combine that with environmental monitoring of gases, noise level, etc. Not all cities are just inland. There are some cities here. This is an example of a rather large container port in the south of Spain. And the port wanted to have visibility on its environmental impact in order to have a sustainability plan. This is very analogous to what a city can do. So here we've added a lot of sensors for both air quality and water quality and climate. Okay. Obviously, this environment is, it's a reasonably tough environment. We've got an aggressive sort of salty air there. So our sensors are totally suitable for this type of real world environment. Okay, so this has enabled the Port Authority to really monitor the emissions, both in water and in air and in noise. The repercussion that it has, looking at this diagram, towards the left, towards the marine ecosystems at the coast, and towards the right, because many ports, of course, are right next to cities. Okay, and they have a repercussion on the city. So our sensors here enable the port to see how they are really affecting the neighboring city. Okay, and this will enable the port to see whether the companies that use their facilities are correctly implementing their environmental plans in order not to pollute in any way the port itself or the neighboring city. And finally, this is right across in New Zealand. This is urban noise and air quality is something that is monitored legally. This, in actual fact, was for construction sites, which are often in cities. These have to be controlled. So this enables the city to really see what the repercussion of the construction is in terms of noise. Obviously, constructions they cause dust to be generated. They cause even if there's a storm, all of the dust and the dirt that's generated by construction can be washed into the groundwater. So Libelium's solutions enable all of this to be monitored. Okay, to make sure that the construction sites in city environments don't cause a very negative environmental impact there. Okay. So this is, again, we've seen this is far away, it's in New Zealand, but this is something that we're seeing a demand for right across the world. It's a very common activity in a city to have not only cars and commercial activity and so on, but also to have construction. And this has, this has to be monitored, how it can impinge upon and negatively affect upon the quality of life of the citizens there. Okay, so that's me pretty much finished with my part. I want to leave a fair bit of time. I've gone through very quickly there, perhaps, but I wanted to leave a bit of time to see if what I've presented there, if people have questions or if they have, something that they can tell us about their experience with environmental conditions and monitoring in cities. So I'll hand it over to the audience and to Convergia also I'll stop sharing now.
Yes, John, that was a great presentation. We have some questions. Is there a recommended number of environmental sensors to deploy in a city? What depends?
Okay, yeah, that's a very common question, and it's a very pertinent question. Obviously, you don't want to be putting necessarily environmental sensors every couple of 100 yards in a city. Okay, what we have to do here, there are different factors involved. It's not an easy thing to answer. Okay, first you have to look at if there are sensitive areas in the city that you want to monitor. For example, schools, for example, hospitals. Okay, these are areas where you particularly want to measure noise level and air quality. Then in the city in general, what we have to do, it varies from city to city. And we have a lot of experience in doing this. Okay, you have to look at the basically a map of the city and the topology of the city and the buildings that are there, and analyze how the air will move through those areas. So this is something that Libelium has experience of doing, and we can help cities to do this, to carry out. It's a case-by-case analysis. So this can give results that you may need to put a sensor perhaps 500 meters away, or 500 yards away, or it may be, half a mile or a mile away. It very much depends on those factors. So there's no one answer there, but we can definitely provide value in helping you to analyze that. Okay, there's not a single answer, and it's not a question of necessarily, or even though that Libelium may love this, filling your city with our sensors, but it has to be done in a way that's a project, and it has to be done intelligently.
Great, thanks. The other question is, how important are regulation and compliance in the adoption of these solutions?
Yeah, very. We, as a driver, as an economic driver for actually installing them, there are many countries like I cited there, New Zealand, and there are others that have environmental protection agencies that will actually levy fines to organizations who pollute more than they should. And I'm sure that's the case in the US also. Okay, so yeah, in terms of being a driver, being a reason, if you like, to actually do this, very much, because you get their return on investment from actually deploying environmental monitoring by not incurring fines. Okay, I wouldn't like to say that you get. It's not designed. This equipment is not designed to impose fines. Okay, I will say that it's not equipment that's put there in order to monitor, and then the EPA can use it to actually impose their fine. No, it's more oriented to continual monitoring to be able to say, look, something bad is going on there. You need to get your pollution down, either in terms of noise, gases, or water, in order to avoid problems. Okay, so regulation there, and of course there are regulations that we comply with in our equipment in order to go to different countries. We look at that case by case. So I hope that answers your question.
Thanks, John. Yeah, we have another question from Cristiano Finamore. How you have been dealing with environmental agencies, since most of them do not recognize or do not consider trustable the data generated by this type of air quality sensors?
Well, yeah, I think that follows on from what I'm saying before. We're not giving mechanisms for the environmental protection agencies to say, even though we assert, and we can assert with data, that our air quality station is a very precise solution. Okay, and we're using the best sensors that we can find that are, obviously cost effective, but they're not. We avoid the cheap and cheerful type of sensors, if you like to say it colloquially. We're using sensors that provide good quality data, so we can really say that that our sensors do provide good quality. But as I say, we're not a tool for the environmental protection agencies to levy their fines. Okay, so we're more, I would say, a guide and a high quality guide for cities, for private organizations, to really accurately assess what's happening on the ground. Okay, that's how you should see our systems, the data that they provide. Okay, and that's maybe true. I agree with the questioner that perhaps the different EPAs say, no, we use our own systems, fine, but we need to provide independent systems that help guide people to make the best possible decisions, whether these people are in the private organizations or in the public organizations.
Thanks, John. We have another question from Bruno Gorriaga. Hi, how the monitoring can help in the decision process of cities?
Right. Okay. Well, plenty of ways. I mean, cities in order to plan how traffic moves. For example, in low emission zones, which is something that's particularly in Europe. I'm not quite so sure in the US, but in Europe, it's something that's used extensively. In order to define a low emission zone, you really need to take in data from the ground. Okay, data on how people move in that area. This isn't, as I was mentioning before, we have systems that can accurately estimate the number of people that there are in a particular area and how they move, and also the environmental conditions on the ground. So if you can imagine in the dashboard of a city, you can't rely on anecdotal data or sending people out to look. You have a lot of data coming in, so you need to really have visibility on what's going on the ground in order to drive your decisions. Okay, so what does that mean? It means the noise level. It means the pollution on the ground. What is the situation before? What you're going to do to try and improve that situation, and then monitor ongoing, and whether your measurements, actually your actions, contribute to reducing the noise level, to reducing the pollution level. Okay, so that's really, it's the eyes and ears of the city on the ground. Saying in an analogy, and it's essential. You can't really carry out meaningful actions without seeing what's happening on those actions. And that's that slide I presented. If you don't have measurements, you can't really manage.
Yeah, and if you look, John, over the last 5 years, right, we've seen an awful lot of changes in major cities throughout the United States, where not only individuals are moving from one area to another, but companies themselves are also moving out of certain areas and looking for new homes to open up or to transfer their business. All the information that you're providing, right? If you look at it just from a marketing standpoint, if a city can market its clean air, its clean water, the low noise levels, those are all areas that not only just the average individual family may be interested in, but also many organizations that are looking to rebuild their companies or open up secondary locations throughout the United States or Canada, that would be very interested in. And that data can be very helpful to bring those groups to their city as opposed to someplace else.
Absolutely, absolutely. And this is really the improvement of the city, the monitoring, the improvement that can bring is something that can make a city more attractive for people to go there, for companies to go there. And also in talking about coastal cities, the work that we do in monitoring water quality is something that makes them more competitive in terms of attracting tourists. Okay, you need to be on top of that. The conventional way of monitoring water quality, of getting samples and then taking them to a lab and 10 days later, etc. Well, this can be made a lot more efficient by IoT solutions and having a real-time continuous monitoring of the water quality. So this is for people who use the coast a lot, surfers and so on, and tourists. This is very interesting, valuable information there. Okay, and they can check it themselves. The city can make this information available to the citizens. Okay, which is another attractive facet of a city.
Agree. And I was doing a little research, John, just over the last few days, specifically on water quality. If you look at in the United States alone, 3 states represent 10 of the worst 15 cities in the entire United States in regards to poor water quality, and those being Texas, Florida, and California. I mean, that's tremendous information if you're a governor, city mayor, that you want to have to make sure that you can do everything and anything to prevent that from hitting that list on a go forward basis. So, and without the data, that it's very difficult to make the changes.
Agreed.
That's right. That's right. Well, the last question for the round would be, what are the main challenges that Libelium faces in the commercial development of these solutions?
Okay. Well, you have to. It starts obviously with with understanding the problem. I mean, the whole cycle of what we do starts with dialogues with our clients, with the end clients, with our partners such as Convergia, and finding out what the problems are, to correctly identifying the problems, and then developing the solution, which has happened over a number of years. We've been refining the solution over a number of years. So you have to get, these are outdoor solutions that have to sit and have to just work autonomously. So a lot of man hours and a lot of experience has to go in to developing the type of products that can do that reliably. Okay, so we have to collaborate here. I mean, you're talking about commercially. Commercially is making sure you understand what's to be solved, and having a continuous dialogue with the people and the entities that have those problems. Technologically, it's getting robust equipment, robust sensors out there, and making the data that they bring the highest quality possible. Okay, obviously there's obviously a cost associated with that. You have to strike that balance, and also in the application level to carry out the the algorithms on that data if necessary to make the data as meaningful as possible in order to help people to make those decisions. So there's a whole combination with the commercial sales part and also the technological part. And that's happened over the whole of Libelium's existence since 2006.
Any other questions, Alessandro?
I think we have all the questions.
John, I would like to personally thank you for taking the hour time coming on and presenting in front of the entire group. Your organization is a tremendous asset. You have been a fantastic market partner to Convergia. For those that are on the call, Convergia is the go-to partner for Libelium in all of Pan America. We go to market through either the channel, we go through wholesale, and we can even do some situations direct depending on the opportunity. So going forward, if you have any opportunities, anything that we can assist you with or help, please do not hesitate to reach out to myself, reach out to John. We will try to get, again, documentation to you on the answers that we discussed, but we'd be very happy to entertain any future opportunities with you going forward. John, any further comments from you?
No, it's a privilege to be able to speak to potential clients, to interested parties, and I thank everybody for tuning in. Okay, and we'll provide the information. And again, I thank Convergia as a fantastic partner right across the American continent that brings a lot of value to Libelium and helps us there tremendously. So yeah, many thanks. And through Convergia, I'm completely at your disposal for questions, for comments, anything that you'd like to comment on, and I'll make the materials available for you. So I'd be very happy to have dialogues with you around this issue, okay, and to learn from you, which is what we're here for.
Fantastic.
Great, guys.
Yep.
Sure. Thank you so much for joining us today. In any case, you can write it up on our mailing, and we're going to send you the PDF of this presentation and also the recording in case you have any doubts or questions or you want to check it out. Thank you so much for joining us, and see you next time.
Have a great day, everybody.
Thank you.